Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the basics operations of a file and how this primitive operation can be combined together to form the other operations made on that particular file system. And what are the attributes that we need to keep in mind when we are performing these operations on a file, and how logs are acquired and released to use files between several processes. As we know that file is an abstract data type, so we need to perform different operations on the file, and files can be defined properly with only the help of these operations that are to be performed on the file. So there are some basic operations like create, writing, reading, deleting, truncating and repositioning of the file, which are known as the 6 basic operation on file. And again then, after knowing about this basics operation, we can know that how to combine this operation to actually make the other file operations like renaming or repositioning and copying and so on. So first we will discuss about the 6 basic operations. The first one is creating a file. To create a file, two things we need to keep in mind. The first one is that we need to have a space found in this memory system of a particular operating system to store that particular file. And the next one is that we need to enter the directory entry in the directory structure for that particular file. The next operation is writing a file. Whenever we want to write to a file, first the parameters need to provided within the system call to make the writing operation. The parameters are the file name and the information to be written on that particular file. First, for the file name, the directory is searched that where the file is located. Then depending on the write pointer, which is a pointer to specify the next write block, which is placed inside the file to write after the fixed position. Now after the write is completed on that particular file, then the write pointer need to be advanced again. Next comes is the reading of a file. For the reading of a file, the system calls need to be specified with a parameter of only the file name and also the block that need to be read out of that particular file. So first the file name is used or indexed for the searching of the file in the directory structure. Then being found the file name, we will look for the file block that is to be read. And here again also the write pointer, we need a read pointer that is to be placed on the line location on which the read block is starting. And after the read pointer is being performed, then it is advanced to the next position. Now, within the use of this read and write pointer, we need an extra overhead of keeping the file offset. But we can reduce this keeping overhead by using a current file position pointer for both the write and read of locking. Now, whenever we are using the current file position pointer, we are telling the file that at the particular position, we will next our operation to be performed. The next one is repositioning a file. After a file is searched, then we can specify a particular position to the file is from the disk or the memory is moved to that particular position. So in this way, we can reposition the file. The next word is deleting a file. Whenever we are deleting a file or need not to be deleted that particular section, then we need to first locate the file, then we need to delete all the information like the spaces or the files that is associated with that particular file to be deleted. So we first delete those information and then we can safely delete that file. The next one is truncating a file. When we want to delete a file's only the content but not the attributes, then we can truncate a file where the contents will be deleted but the attributes or the basic attributes will remain unchanged. Like we can remain unchanged every attributes other than the file length. But let us hear that file length is set to 0 and the file contents are released or the space is released for other files to get used. So these are the 6 basic operations that need to be combined to perform the other operations. Say if we want to copy a file from one other file or to a disk to another position, then we need to first create a new file depending on the position. Then we need to read from the old file and write to the new file. So by combining these 3 operations, we are performing the copy operation. Like renaming of the file, we are reading the new file and then we are creating the file, reading the old block and then copying it to the next file. So by this one we can rename the file. So these operations are performed on the file to be performing defining of that particular file system. So whenever we are using this type of operation, we also may use to set or get the attributes of a file. For instance, we need to know the status of a file or a owner of that file, that is the attributes getting. And if we want to set the user's access control information for that particular file, that is the setting of attributes. Now, whenever we want to operate on the file, every time we need to search the file on that particular directory structure to the actual disk location. So, it keeps the computation time higher and higher. To reduce the computation access time and performance time, then we can keep an open file table which will contain the list of the open files. So when we want to operate on a file, first the open system call is made on that particular file to keep the file open for the next segments. Now the file entry from the directory structure is copied to the open file table and it is remain there until and unless all operations on that particular file has been performed, and after that we can delete the file on the last usage of that particular file. So the create and delete file operations is work with a closed system call or closed files rather than an open file. Some systems implicitly open a file whenever the first reference to the file is made, and then it will remain the file in the open file table until and unless the job which is created or the first reference to the file has been terminated or not. If the file terminated, then it will be removed from the open file type. But most of the operating system require the user to explicitly use the open system call to make the file entered in the open file table. So whenever an open file table is containing an entry of a file that is open and performing of the operations, then every time the operation is being performed and after it is seeing that not the currently used active file is in the open file table, then it will remove the file from that open file table. So we can use the create and delete system call to use this creating and deletion of the open file table. The open system call then also accepts the access control information like the read, write and execute operation mode. So whenever the operation mode is specified in the open system call, first the file is checked against that particular requesting mode. If the requesting mode is acceptable, then only it opens the file in that particular mode. Other than that, the operation is rejected. So after that a file is opened for a particular mode, then it will be performed according to the operation and the access control combination. So when the open file table will contain only the remaining operation of the particular file. So now this becomes easier when a user is using a single process to open the file. But they become problematic when multiple processes wants to access the same file simultaneously. Say for the system files that can accessed by several processes at the same time. So which processes are using which file, it needs to keep track of that particular information. So this type of system uses two tables. One is a per process table, another is a system-wide table. In the per process table, it simply keeps tracks of the files that each process is using, and it included the processes or the particular processes usage about the file in the per process table. So say whenever a process is getting open system call for a particular file, then that file is entered into the per process open file table. For instance, the current process using the access right and the accounting information is included in the per process table. Now the per process table in turn points to the system-wide table. So whenever a file is referenced and it is being opened, then it is put into the system-wide table. First it is put into the per process table, then it is pointing to the system-wide table to reference that the file has been opened. So whenever the file or a particular file is open, it is maintaining a variable which is known as the open count. So the number of processes that is opening a file is equals to this open count number. So whenever a file gets opened, the open count increased, and whenever a file gets closed by a particular process, then the open count decreased. And upon reaching the open count as 0, then we are specifying that the file is no longer active in that particular system. So we can safely delete the entry from the open file table for that particular file. So we need to keep track of some particular attributes that is to be accessed during this open count increment and decrement. So the first attribute is a file pointer. This file pointer is nothing but a pointer to the current file position that is maintaining the read and write operations last location. So if the read and write system call is not mentioned with the file offset as its parameter, then only we need to have a crypt tracking of this file current position pointer. We can use this pointer to reduce the overhead of keeping an extra file offset of that read and write system call. All files are closed, then we need to keep track of the file open count. Otherwise, the operating system may get exhaust of this open file table entry if files are not removed from there. So we are keeping track of the open count or file open count variable, which will increase and decrease upon opening a file and closing a file. And upon reaching 0, we are identifying the last use of the file to delete the entry from that open file table. The next attribute is the disk location of a file. So whenever we want to keep an operation that is to be performed on a file, then we need to locate the file within a disk. Now the information that is used to locate a file on a disk need to be kept in the memory. Otherwise, every time the operation is to be performed, we need to locate the file exactly from the disk location. And the last one is the access information. We need to specify sometimes that the access control information like reading, writing or executing a file. So the file can be opened in that particular mode of access to exclusively use that particular file. Now as a system-wide table is containing process-independent operations like the access data, the size of the file and the location of the disk, so that is independent of the per process table which is need to be stored in that particular table. So now we can sometime refer to a locking of a file inside the file system. And this locking will prevent other processes to access the file when one process is accessing already a file. Say suppose a system lock file can be accessed by several processes. So we can use a lock or a file lock just like as a reader-writer lock. So we can use a read lock or a shared lock that is used to be locked whenever the processes wants to just read the data. But if the process wants to modify the data, then a write lock or exclusive lock is locked on that particular file. So whenever exclusive lock is made, then other processes have to wait until and unless the process that is acquiring the exclusive lock has not released it. So in this way, file locking is being done and performed on the file system to maintain the locking integrity. Now some systems provide this locking mechanism as a mandatory or advisory lock. If the locking is mandatory, then it is to be performed only at a time for a single process. So if a process is acquiring a lock, then no other process can acquire the lock or release the lock until and unless the process is accessing the particular file. Say for an instance that a process is using a particular file and another process, say a text editor, has requested to access a file. So if the previous process has already acquired a lock, then the text editor will not be required to access to that file until and unless the process has released the lock, even if the text editor is not explicitly written to use the lock. Now, in the case of the advisory locking, we are not allowing, the operating system will not prevent the user from accessing the particular file. Rather than it will depend upon the particular text editor to decide that the file is to be acquired lock or not. So it should manually written to write the lock and then use it for the particular process. So in this way, mandatory locking provides locking integrity, and for advisory locking, it is upon the software developers to decide that the file is to be locked before accessing it or not. So Windows uses the mandatory locking scheme, whereas Unix uses the advisory locking scheme. Locking can be done at the time of file as normal process synchronization. Like if several processes wants to use the file at the same time, then the locking integrity as well as the file information should be mentioned, and then it will be done on the operation performance basis. And also the operating system must ensure that no two or more processes get involved in the deadlock while waiting for a file to be accessed for. So these are the file operation and the file operation concerning issues that we have discussed today. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.